It is key for the data-driven approach that the data pool is as complete as possible. This demand is what basically changes the scientific praxis. We remember, the pattern is only true and complete if the data pool is so. We also have to consider that preliminary and negative data are important to build a correct pattern. Thus, these data are also important to have in the data pool. Moreover, the data pool must be free accessible. Only data which are free accessible will be part of the pattern. To summarize, the input to the data pool must be multiple, fast and easy. The data pool needs to be complete, common. That means all data in one pool. Moreover, the data pool needs to be standardized in order to make the data computer readable. The output from the data pool must be open. This means an open access to the data pool. So, the data pool pattern interaction demands a change in the scientific praxis. A multiple, fast and easy input demands social networking is very important. Social network increases the size of the group of people participating in the scientific project. This increases the amount of input. Furthermore, we will see the end of the traditional scientific journal. The traditional publishing process is very slow. It often passes several years between the first results of a project and their publication. We will instead of the journal publishing get high-speed direct publishing to the data pool. We will use open lab notebooks, blogs with unlimited lengths and micro formats of publishing such as tweets. The demand for a complete, common and standardized data pool means all kinds of results get published. Also negative and preliminary results obtain importance. Moreover, papers need to be written in a computer-readable format in addition to the human-readable format. A demand for a data pool with open access results in open access publishing and in open source licenses. Also, the filter has influence on the scientific method. As we saw, the logical truth is unaffected by the kind of filter. This means that different filters are possible. Thus, idealistic and materialistic concepts are possible. We get a range from robotic to art-driven science. Also, non-scientists can make valuable contributions to research projects. The feedback to the data pool changes the scientific method and praxis. The digital conversation gives context for data. We work with complex systems with dynamic feedback. This results in an end of monocausal reasoning. We get dynamic publishing with preliminary results and post-publication review instead of static papers. Moreover, we will get an unseen speed in science, since highly technical problems are more likely to be resolved by a larger group of people who cooperate. Concerns about our career are what basically delay a lot of scientists to move to the world of Science 2.0. I will give a few examples of such concerns. How is the intellectual property, the authorship assigned? What credit system shall be used? Are we looking stupid and unprofessional if we publish uncompleted, dynamic documents? How do we protect our data for plagiarism? How is quality assured? Does frequent publishing result in lower quality? How do we survive in an open environment in respect to money and career? Do we need protection from our competitors, or can we change to be collaborators? How do we gain trust for our applications? I will finish with the good news. Faster and greater cooperation and collaboration will speed up the scientific discovery and the career, especially of the early adopters. Thank you a lot for watching and your interest. I hope you enjoyed the talk. I would appreciate your comments. If you have any questions, comments, please contact us. This talk is published under a Creative Commons license CC BY SA 3.0.